All right, let's look at a couple of washers examples. Same process as for the discs. You want to get a picture so you understand what's going on, and you want to set up the integral and hopefully be able to evaluate it, but if not, pop it in the calculator. So here we've got y equals square root of x, y equals 2, x equals 0, and we're rotating about the x-axis. And as with discs, we always will be rotating about the x-axis when we're dealing with washers. So take a look at this graph. We've got y equals 2, which is a horizontal line. We've got x equals 0, which is the y-axis. And then we've got y is the square root of x, which is 0, 0, 1, 1, and then 2, 3, 4, 2. So our region looks like this, sort of a sucked-in triangle shape. And we're rotating that about the x-axis. So we're going to have our mirror image down here, and then draw a couple little ovals at the ends there to sort of get the sense of what this shape looks like. And I always think that this shape looks like a shot glass, sideways shot glass there. Phi Theta Kappa, our honor society, used to sell shot glasses in their catalog. They're very nice little blue shot glasses. And when drinking became a bad thing, the honor society had to distance itself from that image, so they did not stop selling shot glasses. They started selling toothpick holders, because that's what people use them for, I'm sure. Right, now, this is a little different than the picture we looked at before, but if you are going to rotate this about the x-axis and you're going to slice this into pieces, right, take this slice here, each of these slices is going to be a washer. You're going to have that hollow part in the middle, and then you're going to have the outside edge, right, and there's going to be glass here, but there's going to be emptiness in the middle. So this is definitely washers. And our setup for washers is pi times the integral from a to b, and those are pretty obvious here, from 0 to 4 where it stops. The outside function, now the outside function here is this horizontal line, which is y equals 2. It's always the same. Every single washer along the way is going to have an outside radius of 2. So that's going to be 2 squared. Minus the inside radius is always going to come from this function here, which is the square root. So the square root of x squared dx. Very simple. Outside function minus inside function. Sometimes that function is a constant, sometimes it's not. Usually it's not. So this is what? 4 minus x dx. A very simple integral this time. It's going to give us pi times 4x minus x squared over 2 from 0 to 4. And always lucky when we end up with a 0 for the bottom limit, because we don't have to actually plug that in if we're dealing with polynomial type equations. When we're dealing with trig, something different. 4 times 4 is 16, minus 16 over 2. So it's going to be 16 minus 8. And we get 8 pi for the volume of this. Now, we're not talking about how much would fit in the glass here. We're talking about the volume of the glass part itself. Now, if you think back a couple lectures to when we did that bullet shape, you probably recognize that bullet shape right here, the square root from 0 to 4, rotated about the x-axis. And we found the volume of the cylindrical box for the bullet was 16 pi, and that the bullet occupied exactly half of that. Well, this shot glass, quote unquote, is the other half of the shape, or the other half of that cylindrical box. So in other words, if you put that glass bullet inside this shot glass, you would have a solid cylinder with no space. Right, let's do one more. It's not supposed to be under there. We'll get marks on it. Got marks all over my table. I'll get marks on next time's notes. y equals 2x, y equals x squared, and we're going to rotate that about the x-axis. Again, always the x-axis. If we look at this shape, we know what x squared looks like. Goes through 1, 1, and goes through 2, 4. You're noticing a lot of 2s and 4s here, aren't you? It's because I like to keep the numbers really nice for these. Don't expect them to be always as nice in the homework, but you've got time to do them. I don't want to spend time doing ugly algebra on these videos. Our other surface here, or other curve, is 2x, which is going to go through 1, 2 and 2, 4, and is a straight line. So we found the area of this shape before. It was very small. I don't remember what it was. I think 4/3, something like that. And this time we're looking at what are we going to get if we rotate that about the x-axis. That's going to be down here. So I get kind of a thin shell here almost. I could describe this a couple different ways. If we were thinking that that direction was up, that would look like one of those hats that the rickshaw drivers wear, those wide brimmed straw hats. If you're from a coastal state like me, you would think of this as a limpet. A limpet is a monovalve, has a shell that kind of looks like this, and it sucks up on rocks. So you get a rock there and the little limpets, and the creature lives inside. But I don't know what you'd want to call that. The volume is going to be something fairly small because that's very thin, right? Very little area rotated around there. So our volume setup is going to be pi, my bad, from 0 to 2, right? Our x's are going from 0 to 2. And our top curve is the straight line, the one that's farthest away. So that's going to be our 2x squared minus our inside curve, which is x squared dx. Okay, so again, it's the same thing. It's the outside curve minus the inside curve, both of them squared. And that's going to give us 4x squared minus x to the 4th dx. And I'll just run through this one real quickly. I don't want to leave you without an answer here. That's going to be 4x cubed over 3 minus x to the 5th over 5 from 0 to 2. Okay, so that'll be pi times x cubed is 8, so that's going to be 32 over 3 minus 2 to the 5th is also 32 over 5. If we multiply this one by 5 over 5 and this one by 3 over 3, we'll get a denominator of 15. And we'll be subtracting 5 times 32 minus 3 times 32, which is going to be twice 32, which is 64. So 64 over 15 pi is the volume of that shape. I have no idea how to actually approximate that because it's so far from any shape that I can find the volume of that I'm not going to trust my estimate anyway. 64 over 15 is approximately 4.5, something like that. That's a relatively small number, so I'm going to trust it, and see you next time.